Assalamualaikum warahmatullahi wabarakatuh to all my lovely Form 5 students. So, how are you doing? I hope you're still doing well because we are in our 22nd day of MCO. Okay, so hope you still stay at home, stay safe. We do not know when will this MCO will end. Alright, without wasting our time, let us continue our lesson in oxidation and reduction. For the example of redox reaction number 4, which is the transfer of electron at a distance. Okay, first of all, redox reaction can occur under two conditions. Condition number 1, when you have oxidizing and reducing agent that are in contact, meaning they are touching each other, they are in one beaker, in one container. So just the experiment is just mix the oxidizing and reducing agent in a test tube. Okay, no problem. But what if when you have the second condition? The second condition is when you have oxidizing and the reducing agent are not in contact, meaning it is separated at different container. Okay, can the redox reaction still occur or cannot? Okay, it still can occur, but we can do it in a redox cells. So what is a redox cell? So let us look at this setup apparatus. What do we have here? What do we have here is the okay, we have reducing agent in one side and we have oxidizing agent on the other side. Okay, so reducing agent is the one that will act as the oxidation process that occur, oxidation process. Okay, oxidation process referring to oil rig. You still remember oil rig? Oxidation is loss of electron. Okay, meaning this substance here, this solution here will loss of electron. Okay, so when it lost electron will accumulate here. There will be a lot of electron here waiting to be donated. Okay, for the electron, when the electron has been released, the electron will move through these connecting wires. Okay, move to the other side of the oxidizing agent. Oxidizing agent is the one that will undergo process of reduction, which is, if you still remember, RIG is the reduction process is gain of electron. So this substance here, it will accept the electron. This one will accept electron. This one will donate electron here. Okay, and this oxidizing and reducing agent is separated by this dilute sulfuric acid, and this is what we call as salt bridge. If you still can remember what we learned in our chapter 6 form 4 electrochemistry, for the voltaic cell we have salt bridge also. And this setup apparatus occur in a U-tube. Okay, alright. Okay, this is the process actually, the formal process. First of all, the solution containing reducing agent will act as the negative terminal. Remember, negative terminal because electrons accumulate there. The solution that contains the reducing agent donates electron a lot, and then electron will accumulate and electron will be there, so it is called as the negative terminal. Okay, next, the reducing agent undergoes oxidation with loss of electron, the same thing. Okay, what's next? Electron produced will flow through the connecting wires to the oxidizing solution. The movement of the electrons from the negative terminal, it will move to the other side, to the positive terminal. At the positive terminal, we have solution containing oxidizing agent. Oxidizing agent, the one that will undergoes reduction. So what happened? Reduction process accept electron. So still occur donation of electron negative terminal, donate electron, while where is it? Positive terminal, accept electron. So donate and accept electron at the same time, it is redox reaction, occurs simultaneously. It's just the movement of electron, the transfer of electron occur in the external circuit, okay, in the wire. Okay, the sulfuric acid or the salt bridge, actually it is salt bridge, and the function of the salt bridge to separate the oxidizing agent from the reducing agent, and also to complete the circuit, the electric circuit, so that the ions can move through it. Okay, movement of anions and cations lah. Anions will move to anode, cations will move to cathode. And this sulfuric acid can be replaced by whether you have sodium or potassium chloride solution or sodium or potassium nitrate solution. Okay, next. Let's look at this lab work 3.5. I've been prepared for you 3 examples. So let's look at example number 1. The reaction between potassium iodide. Okay. Potassium iodide solution, and we also have potassium dichromate solution. Okay, this one is potassium iodide, and this one is potassium dichromate solution. Remember, the first thing that you should do when you have this type of questions is to identify which one is the oxidizing agent and which one is the reducing agent. So as we have learned before, oxidizing agent example, the famous example, whether you have potassium dichromate or potassium manganate solution. So if you have potassium dichromate as the oxidizing agent, automatic the other one will be the reducing agent. So this is 2 marks already when you identify oxidizing and the reducing agent. Okay, and then step number 2, to determine the oxidation and reduction process, okay, whether donates or accept electrons, and predict the observation. That's our second step. Okay, let's look at second step. For oxidation process, oxidation means process of donate electron. Okay, when donate electron, understood, oxidation is the reducing agent that donates electron. So we have potassium iodide to donate electron. In potassium iodide Ki, the one that involved in the reaction is I, okay, iodide, because when we calculate the oxidation number for iodide ions change. Okay, from this one is -1 for the charge, this one is elemental state 0. Okay, if potassium, before and after, the oxidation number does not change, so potassium do not take part in the oxidation and reduction process. Okay, so proceed with potassium iodide. When you do the half equation, what will you get is from iodide ion, okay, iodide ion Ki, it is in iodide ion, it donates electron, donates the discharge, the charge of itself, so it become neutral. Neutral is I2, iodine cannot stand itself, cannot stand alone, so you have to combine with itself to form a molecule. Donates electron meaning you have to add electron after the arrow. Okay, balance the equation. You have I2 after the arrow, so you put 2 in front of I minus before the arrow. Then this is 2 electron, so you should add 2 electron also after the arrow. Okay, so you have marks number 3, the process of oxidation. Okay, the color change. Okay, color change. First of all, what you need to know is the color of Ki. Ki is all salt solution are colorless except the one that have iron 2, green, iron 3, brown or copper ions, blue kan. Jadi, if Ki, it is colorless. So, during the reaction, this I minus, okay, during reaction, this I minus donate electron and it will form iodine molecule plus 2 electron. So, what is the color of iodine? Iodine color is, actually it is colorless, pale yellow, very light yellow. So, what do I have to write here? Maybe I should write pale yellow. Okay, iodine. Okay, so that's a color change from colorless. Okay, colorless change to yellow or pale yellow. Okay, that's the observation. Potassium iodide discolors, whereas iodine is yellow in color when dissolves in water. Colorless to yellow. Okay, that one is for oxidation. Okay, let's do the reduction process. Reduction process will be this oxidizing agent. Then oxidizing yang kita ada tadi, K2Cr2O7. This is potassium dichromate acidified. It is hard to know to write down. You should try. Very not cooperative, this pen. Dichromate. Okay, very ugly. Okay, potassium dichromate. You just leave the potassium alone. Just take the chromate ion or dichromate ion. So this is the dichromate ion. Kenapa leave potassium alone? Because the oxidation number does not change. Okay, dichromate je yang undergoes process of reduction. Okay, dichromate dah ajar dah malam hari tu. Dichromate dia akan change pergi ke Cr3, chromium ion. This one is chromium ion. And then bila dia jadi Cr3 only, kita do not have oxygen after the arrow. So, nak jadikan ada oxygen, you have to plus H2O. And then, before arrow, tak ada hydrogen. Jadi, tambahkan hydrogen ion. Then, calculate the oxidation punya charge. Both sides. Jom kita buat sama-sama. Okay, Cr dichromate Cr2O7, charge is 2 minus. Okay, and then dia jadi chromium ion. Okay, tengok ada O before arrow, so sini kena tambah with H2O. Okay, sini lepas arrow ada H, so sini kena tambah with H+. So sekarang all the elements are equal. Semua dah ada dah presence. Okay, hydrogen here ada, hydrogen here ada. Cr ada sini, Cr also ada sini. Oxygen ada sini, oxygen ada sini. Cuma not balance in the number of the atom. So jom balancekan dia. Cr, we have Cr2 here, so you can put 2 Cr in front of the chromium ion. Next, oxygen, you have 7 oxygen here, so you can put 7 here, so you will have 7O. Then hydrogen, you have 7 times 2, 14 hydrogen, so kat depan hydrogen sini you can put 14 also. Yeah, 1 4. Okay. Jadi all balance. Cuma in terms of the electrons, only not balance. So we calculate the charge. This one 14, then charge dia adalah plus. So this one charge dia adalah positive 14. Yang ni charge dia negative 2 only. Sebab do not have any number here. Okay, so positive 14 and negative 2, bila tambah dua ni, it will produce positive 12. Okay, hasil dia. This side, 2 times 3 equals to positive 6. Yang ni is molecule, do not have charge, zero charge. So, tambah 2 ni becomes positive 6. Jadi, between positive 12 and positive 6 electron, where you should add the electron to make it a balanced charge. Here, right? How many? Tambah with 6 electron. Plus 6 electron, barulah dia akan jadi positive 6 juga. Okay, saya tulis balik biar cantik sikit. Overall, the half equation for the reduction process, it will be 14H plus Cr2O7 2 minus plus 6 electron produce 2Cr3 plus ion plus 7 H2O. Okay, itu adalah half equation. Okay, which is this one. Observation. Potassium dichromate is orange in color. Then, bila dia form chromium ion, the color is green. So, ingat untuk potassium dichromate, orange turns to green. Okay. The chromate ion is orange in color, whereas chromium ion is green in color. Okay, step 3. You have to identify the anode and the cathode. Remember, anode cathode ni negative or positive terminal lah. Okay, in redox reaction, in redox cells. Okay, redox cells ni contoh dia macam voltaic cell. Voltaic cell dengan electrochemicals, electrolytic cell lain kan. So, electrolytic, kalau ingat electrolytic cells, dia terbalik with the voltaic cells. So, same goes with these cells, these redox cells. So, if anode is referring to the negative terminal. Okay. Whereas cathode is referring to the positive terminal. So, for the electrode P, tengok balik soalan tadi. This one is electrode P. So, this electrode P dia adalah anode. Okay, because anode is the one that donates the electron. Oh, dia besarkan. Okay. Nah, electron comes from potassium iodide. So, this one lah anode. Or negative terminal. Vice versa, for electrode Q ni, since dia akan accept electron, gain electron, dia akan jadi positive terminal. Or this one will be the cathode. Okay, then movement of electrons is from P, from the anode or the negative terminal, to Q, sampai dekat Q. Okay. Okay, so step 3 done. Step 4 also done. Step 5 also done. Determine the direction of flow of electrons from electrode P to electrode Q. Remember, the movement of electron must be from negative terminal to the positive terminal. Okay. Yang half equation tadi. Okay. Just now we already write the half equation for both of the reaction. How about the overall equation? Potassium iodide, balancekan dia sekejap. I2 2I here. This one will be 2 electron here. Okay, from dichromate ion, accept 14 hydrogen plus 6 electron to form 2 chromium ion and 7 H2O. So, kalau nak buat overall equation, remember you just make sure the number of the electrons are equal. This one is your right hand side. Right side. This electron is on the left side. So you must make sure right and left side adalah equals number of electrons. Okay, right side tu meaning it is after arrow. Okay, kalau yang left side tu maksudnya saya merefer kepada arrow dia before the arrow. Jadi nak cancel all the electrons mesti both sides tu kanan dan kiri are equals. Tapi sekarang ni 2 electrons on right side, 6 electron on left side, jadi tak equals lagi. You have to make it equal by times kan equation ni with 3. Jadi kalau times 3, this one will be, kita tulis equation baru Dia akan jadi times 3, 6I minus produce 3I2 plus 2 times 3, 6 electron. Okay, 6 right and 6 left barulah boleh cancelkan all this electron. And finally, just combine them together. 6I for the reactant plus with Cr2 O7 2 minus plus with, we still have 14 hydrogen tapi elektron dah tak ada. So teruskan ke product. Untuk first equation, products we have iodine I2, 3I2 sorry, and electron dah habis. For the second equation, we have 2 chromium ion with 7 H2O. So this is the overall equation. Okay, dapat faham? Altogether dia ada 5 steps. So you have to follow the steps. Okay, nak tengok yang second example. Okay, for the second example, is the reaction between iron 2 sulfate solution, color of iron 2 sulfate, green, and then acidified potassium manganate, color dia adalah purple. Okay, ikutlah step tadi. First step, apa yang kita kena buat? Jom kita buat sama-sama. Okay, first step tadi, you have to identify the oxidizing agent and the reducing agent. So which one you guess will be the oxidizing or reducing? Dah memorize? Yang ni kan, this one is the oxidizing agent. Vice versa, this one is the reducing agent. Okay, dah untuk first step. Second step, you have to determine the reaction, the oxidation and the reduction process, and also to predict the observation. Jadi observation tu later, kita buat dulu dia punya half equation. Untuk proses kena buat half equation. Half equation, okay, which one first? Reducing first. Reducing agent means dia akan undergo oxidation process. Oxidation means dia akan release electron. So iron sulfate, yang mana yang involved in the reaction? Iron or sulfate? Iron. Okay, this is changing iron 2 becomes iron 3. Dia donates electron, so makin increases in the charge, jadi become 3+. Donates means tambah electron here. So this is the half equation for the oxidation process. Can you see the charge here? This is 2 plus, while this is 3 plus. Okay, done for oxidation process. Then electron yang dia release akan moves into the external circuit to oxidizing agent. Sampai at oxidizing agent, the one that will accept either potassium or manganate. Manganate, right? Untuk reduction. Reduction, dia akan gain electron. So, manganate MnO4 ion. Saya sambung ke sekejap ni sini Okay, ni. Oxidation tadi we have iron 2 change to iron 3 plus electron. For reduction, manganate ion is MnO4 minus. MnO4 minus. It will change to manganese ion. It's Mn2 plus. Okay. Ada O sini, so this one have to add with H2O. Ada H here, so you should add with hydrogen ion here. Okay. Then hydrogen already there, manganese and oxygen also done. So electrons lah. Electrons, tengok charge. Balancekan dulu. You have oxygen 4 here, so you should put 4 oxygen here. Okay, so when you have 4 times 2, 8 hydrogen, so you should put 8 hydrogen here. And the charge, this one is negative charge, so negative 1. While this one is 8 times 1, positive 8. This one, positive 2. And water is 0. All together, negative 1 plus 8 is positive 7. All together, positive 2. So you should add electron here. Excess of proton. So plus electron here. How many electrons? Nak make it balance, 5 and 7 and 2 should plus 5 electron. So you have your half equation for reduction. Okay, next. Second step baru second step. Still in second step, observation. Observation, never mind. Observation, I want to show you this one. Okay, for observation, iron 2 sulfate, iron 2 means the color is green color. So from green becomes iron 3 ion. This one is because of iron 2. So change to iron 3, brown in color. So the solution change from green to brown. Okay, this one is the confirmatory test. When you check with potassium thiosulfate solution, it will gives a blood red for the confirmation. Ada ion 3 ion. Okay, and then on the other hand of the U-tube, on the other side, you have a purple color of potassium manganate. So when manganate change to manganese, manganese is colorless. Okay, jadi change of color dia from purple to colorless. Another observation, the third observation is the galvanometer needle is deflect, means ada electric current that flows. Okay, because electron are moved from iron 2 sulfates to potassium manganate. Okay, electron flow through the connecting wires. Okay, so that, itu je lah observation kita. Okay, yang ni untuk equation lah. Equation yang teacher dah tulis tadi From ion 2 becomes ion 3, donates electron. So plus electron right there. And then from manganate ions, balancekan equation juga lagi. This one will be 8 hydrogen kan tadi, with 5 electron here. Then manganese 1 and H2O is 4 H2O. Tak silap tadi. Okay. So boleh tak buat overall equation? Okay, overall equation. Jom kita buat overall equation. Ada 5 electron before arrow. Jadi elektron kat sini after arrow ada 1 only. So equation ini you have to times with 5. Equation baru dia. This one kita dapat 5 Fe2 plus produce 5 Fe3 plus 5 electron. Jadi 5 electrons selepas and 5 electrons sebelum boleh cancel it out. Jadi tulislah balik. This one is 5 Fe2 plus with this one MnO4 negative plus with this one 8 hydrogen. Electron dah habis. Okay, for the product, this one 5 Fe3 plus, this one manganese ion, and this one is water, 4H2O. Jadi itulah half equation. Overall equation. Okay, last one. Example number 3. I give you iron sulfate and bromine water. So step number 1, remember, identify which one is the oxidizing agent, which one is the reducing agent. Tapi just now kan baru je tengok iron sulfate as the reducing agent. So this one lah reducing agent. This side akan undergoes reduction ataupun oxidizing agent. Okay, first step identify, second step adalah process. Okay, process oxidation and reduction. Oxidation macam biasa tadi, Fe2 plus become Fe3 plus. Oxidation means loss of electron, so you should plus electron here. Okay, while for reduction, since you have bromine water is Br2, then reduction is gain electron. This one donate electron. Okay, gain electron to form. Of course, from bromine molecule it will form Br minus bromide ion. Ni yang tadi sebut salah. This one is bromine, INE, because it is in the form of molecule. While this one, sebab dia adalah ion, so kita panggil dia as bromide. Belakang dia IDE. Bromide is ion, bromine is molecule. Sebut betul-betul. Okay, balance equation. We have 2 Br here, so you put 2 in front. So 2 electron ni. So also have to plus with 2 electron. Okay. Okay, color change. Observation, right? Observation or color change. Color change. Iron sulfate from green dia akan change pergi brown. Okay, because brown ada iron 3 plus. Kalau green dia ada iron 2 plus. For this one, bromine water is brown. Tengok color dia brown. Dan bila dia jadi bromine water, bila jadi Br minus do not have color already. So it is colorless Br minus. Okay, itu adalah observation. So settle step 2. What is our step 3? Step 3 is the identify the anode or cathode. Okay, anode cathode. Okay, since this one reducing agent ataupun dia donate electron, so P anode, because P donate electron sampailah dia become negative terminal, so much electron has been donated and accumulate there, so negative terminal. Vice versa, this electrode Q adalah cathode. Cathode, a place to accept electron or positive terminal. Okay, step number 5. Step number 5, dia akan berlaku movement of electron. Identify movement of electron from negative terminal through the external circuit sampailah ke positive terminal or the cathode. Step number 5. Now, observation tadi color change, right? Color change. Green iron 2, brown iron 3, check with potassium thiocyanate or potassium hexacyanate. You can have a blood red coloration. Okay, ferret tu dark blue. Bromine color from brown it change to colorless. Okay, galvanometer needle deflect. Okay, and then electron flow out from iron sulfate P to bromine water Q, from electrode P to electrode Q. Equation kita dah buat tadi, cuma belum combine overall equationnya. This one 2Br, so here also 2 electron, so this one you have to times 2. Okay, times 2 dia akan jadi 2Fe 2 plus, sini pun akan jadi 2Fe 3 plus 2 electron. So 2 electron sini can cancel out, salin balik. You can have 2Fe 2 plus Br2 produce 2Fe 3 plus 2Br minus. Okay, final guide to solve problems related to transfer of electron. First step, you should know that oxidation will always happen at anode. Oxidation means loss of electron, donates electron, anode. Okay. Number 2, reduction always happen at cathode. Gain electron, accept electron, reduction. So it will occur at cathode. Number 3, anode is the negative terminal, while number 4, at cathode is the positive terminal. I know it might be confusing for this example. Number 4 ni paling susah sikit. Tapi apa-apa hal, you can PM me, ask me questions, solve your problems. I'll be there to help you. Alright, that's all. Thank you. Good night.